Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, Subject Code OEC 754 Medical Electronics, Unit 4, Topic Surgical Diathermy. Objective to understand the concepts of surgical diathermy and its principle. A surgical diathermy, it is used to assist the surgical procedures by providing cutting and hemostasis. Stopping bleeding is known as the electrosurgical unit. Principle. Here, the electrosurgical unit consists of two electrodes, one being called the active electrode and other being called the passive or dispersive electrode or a patient path. Here, a high frequency electric current is passed through this electrode due to far smaller cross section area. Then the current density at the active electrode is far greater than that the passive electrode. So as a result of this, the tissue underneath the active electrode is heated up to the destruction. And then electrotomy, that means process of cutting the tissue through application of high frequency current. Fulguration, it is the process of distracting the superficial tissues through application of high frequency current without affecting the deep seated tissues. Next one is coagulation. It is the clotting of blood through application of high frequency current. Desiccation, it is a localized destruction of the deep seated tissues through application of high frequency current. So here we have different current waveforms are used for different applications such as coagulation, desiccation, cutting and bloodless cutting. Then the desiccation or coagulation are achieved by damped sinusoidal pulses of frequency from 250 to 2000 kHz and power from 50 to 200 watt. Here some waves are there shown in the figure. That means the first wave is used for the cutting is achieved by a continuous sine wave of frequency from 500 to 2500 kHz and the power 100 to 750 watt. And the next one is the bloodless cutting is achieved by combining the above two waveforms. The resulting waveform is known as blended waveform. Then the block diagram. Here the RF oscillator provides the basic high frequency signal which is amplified and modulated to produce the coagulation, cutting and blended waveforms. Then the function generator produces the modulation waveform according to the mode it is selected by the operator. Here the output of the modulator is amplified to desired power level by a RF amplifier. Then the RF power amplifier can be turned on or off by hand switch and the active electrode or a foot switch. Then the output circuit couples the output of the RF amplifier to the active and the passive electrodes. Then the electrodes will come in various sizes and shapes depending on the size of the electrodes. Hazards in electrosurgical unit. First one, burns. In the burns, it is the presence of moisture or the accumulation of prepping agent or blood or any other liquid in between the patient body and the dispersive electrode increases the conductivity and hence the current density at those points of contact, leading mild or severe burns at those points. The improper contact of the dispersive electrode to the patient body due to bony areas leads to burns, and the burns occurs at the points of contact of monitoring electrodes due to ground loop. And the next one is electrocution. In this electrocution of the patient occurs due to involuntary contact of the patient with the active electrode or leakage of currents due to faulty ground. Then the explosion hazards, when the active electrode involuntarily comes in contact with a cleaning agent such as ethyl alcohol or with the tubes carrying anesthetic gases. Here some aspects in electrosurgical unit to avoid burn. That means it is a perfect contact of the dispersive electrode to the patient should be ensured. And to avoid explosion hazards means to contact of the active electrodes with cleaning agents or tubes carrying the anesthetic agent should be avoided. Thank you.